Today we're going to hear a slightly different take on object-oriented programming, maybe a little more like what the rest of the world thinks, but not entirely like what the rest of the world thinks. This chart that Jordy is writing on the board actually is about where the rest of the world stands relative to what Engels is talking about. To help you understand the lecture, I've put up on the board here a translating dictionary between his names for things and our names for the same ideas. These three are actual things in the language. That's why they're in capitals. When he talks about a small integer, he doesn't mean 6 or 7. He means anything less than, absolute value less than 2 to the 31st. He's going to define a class point in Smalltalk. And these three boards are the equivalent definition of class point in the obj.scheme OOP language. So if you can leave these board lights on, not the tables, but the boards, while we're watching the video, thanks, that'd be great. Go. This chart up on the right here, a lot of the last part of that talk was, what about this feature, and what about this feature, and what about this feature? And a kind of subtext of that was C++ had just come out and was sort of paraded as the big new object-oriented language of the future. And they're pointing out that C++ isn't actually object-oriented at all. It doesn't have first-class procedures. It doesn't have the uniform reference that he was talking about, where everything is an object. And it didn't have automatic storage allocation. So our object-oriented system, well, Smalltalk, of course, is yes, yes, yes. The object-oriented system we're using this week, obviously it has Lambda. It has automatic storage management. It does not have everything as an object. So in our system, numbers, for example, are just numbers. And it's only the abstract types that are objects. And that whole business about can you use a rational number in the coordinates of a point in a rectangle addresses that if you think of numbers as not being objects, then you can't invent exact rational numbers and have them fit in with everything. So how is industry stacking up? So the next improvement on C++ was Java. Everything is not an object. Numbers aren't, the same as in our system. What they do have is a parallel set of object classes that are named after numeric types, but those classes can't do arithmetic. So it's like you can have numbers that aren't objects, or you can have numbers that can't do arithmetic. It's a big mess. A big, big, big improvement in Java is that it does have automatic memory management, and that eliminates a big class of bugs. And does it have Lambda? Well, it has something called anonymous classes, which got shoehorned in about the 3rd or 4th revision of the standard, that you can kind of use as lambdas if you really stand on your head, but it's not designed in. So this is sort of where things stood as of, when I started giving this talk 25 years ago. Since then, there's JavaScript, a language with a terrible name because it has nothing to do with Java and is in fact better than Java. Does have Lambda, does have automatic storage management. What does kind of mean? Okay, you can treat things as objects, but sometimes they act funny. Okay? It's making progress. Ruby, which is another not so widely used because it's better, but real-world industrial language is a yes, yes, yes. And they're even talking about now putting Lambda into C++ in its latest revision. So this is all good news, actually. It means that good ideas do eventually kind of filter down into industry. So we're not totally wasting our time here at the universities. On the other hand, these languages are fairly hideous, and it's not just because they have bad designers that they're hideous. It's because they kind of try to do, they're based on every good idea at once. So when you program in Scheme, the big organizing idea of Scheme is first-class procedures. And every problem that comes up is done in a way that fits into that framework. So it has a very uniform syntax, and it has a pretty simple semantics. Simple not in the sense that it's intuitive necessarily, but in the sense that there aren't very many rules. Smalltalk, which you saw some examples of in this talk, is very, very different from Scheme in its notation and its ideas and everything, but it has the same simplicity. In Smalltalk, everything is done by sending messages to objects. And that means, again, a very simple set of rules and great generality. In industrial languages, so far, they haven't been brave enough. Instead, what they've done is said, well, this is a good idea, this is a good idea, this is a good idea, and they try to cram them all into one. Eventually, maybe they'll even learn that lesson.